All right, so this is the quick review operations in scientific notation. I will try to be brief here. Remember, adding or subtracting, the concept is like adding like terms. So remember, a -4 of them and another -3 of them is a -7 of them, and what is the thems? Ends to the 5th power. So that's the concept, and that's how we're going to add or subtract scientific notation numbers. So notice we have the exact same thing here. So I'm going to add the coefficients, 3 of them and a -9 of them is going to give me a -6 of them. What are the thems? Times 10 to the 5th. Now let me remind you, make sure you have like terms, meaning your exponents are the same. That's necessary and needful. You say, what if I don't? Well, remember what we learned at MathLite? All right, you have to take the smaller one. That was the key tip, right? Take the smaller one and change it to match the larger one. Okay, so I get this 6. Decimal point is here. I'm going to make this smaller, right? Oops, excuse me. I'm going to make that smaller, right, so that the decimal point is there, so that this can go larger. All right, so let me rewrite. Now I have 0.6 times 10 to the -6th. Now we have like terms, and now I can add the coefficients. 0.6 of them and 9.5 of them is 10.1 times 10 to the -6th. Am I done? No. Because remember, I've got to leave it in proper scientific notation. I'm going to have to make this number smaller, so I need to make this larger. And so I end up with 1.01 times 10 to the -5th. And that was a technical problem, and we went into detail on those concepts at mymathlite.com. All right, so let's take a look at multiplying. Now remember, in multiplying, you multiply the coefficients. 2 times 7 is 14, and you apply the exponent properties, the exponent rules, right? X to the a times x to the b equals x to the a plus b, right? And so where do we end up with? 14x to the 6th. That's the concept of multiplication. You multiply the coefficients and you apply the exponent rule to the exponents. Okay, so 7 times 3 is 21, and it's going to be times 10 to the -2 plus 7, right? And where do we end up with here? So right now I'm at 21 times 10 to the 5th, and again, I'm not in proper notation. I need to make this smaller, so I need to make this larger. And you end up with 2.1 times 10 to the 6th. All right, how about division? So division, again, if we take a look at just dividing normally, you would take that 6 and you would divide it by the 3, and you'd get a 2. And remember, the exponents would be x to the a, the top, minus the bottom. And this would end up with 2x to the -10th, right? 2x to the -10th. Well, it's the exact same thing in scientific notation. Take the 2 and divide it into the -4.8. So let me do it below here. So -4.8 divided by 2 is a -2.4 times 10. And what do you do to the exponents? You subtract them. 3 minus 8. Where do we end up with? -2.4 times 10 to the -5th. All right, so remember, adding or subtracting, it's like adding like terms. Multiplying, you multiply the coefficients, you apply the exponent rules to the exponents. Dividing, you divide the coefficients, you do the exponent rules to the dividing of the powers of 10. All right, that's the idea, operations in scientific notation.